This video covers section 2.R.8 called Linear Inequalities in One Variable. We've looked at this topic before. We're going to add a little bit of a different concept to it for the types of intervals. And that's sometimes what Hawks asks for, is for you to identify which type. There are three, according to this classification. There's other types of intervals such as finite versus infinite. But for the ones that I saw in the questions, x being the variable between the given numbers a and b, where it's a is less than x is less than b. In interval notation, that's denoted with the parentheses around the endpoints separated by a comma. I'm not going to graph it here, but this is the notation. This is the algebraic notation. This is the interval notation. And that's called an open interval. I'll come back to why in just a second. Let's look at this one. A is less than or equal to x is less than or equal to b. Also, you could say x is between a and b. Inclusive, so including a and b, including the endpoints. And we denote that in interval notation by brackets. So all the numbers between a and b and a and b. And that's called a closed interval. So the difference between open and closed, the open interval does not include the endpoints, and the closed interval includes the endpoints. Now this one, a is less than or equal to x is less than b, is a mix of those two. We're including the a endpoint because it's less than or equal to. We're not including the b endpoint because it's strictly less than. So this is the interval from a to b, including a, not including b, and it's called half open. Sometimes clopen is what they call it, closed open, clopen, but Hawks calls it half open. So let's look at some of the types of problems. The first one I got was a single inequality as opposed to a compound inequality, and it just gave me x is less than or equal to 6. The graphing part of it and the identifying the type of interval were the whole problem in this case. I didn't have to actually type the interval notation. I'm going to write it just for your information, but the thing that I had to choose was this symbol in order to graph, but also to identify this as a half open interval. So it's a half open interval, and that's what they wanted me to select, as opposed to open or closed, half open, because we're including one endpoint and not. Now, why this? It's not a sandwich of x between two numbers. This one is because if I graph it, the number is 6, and less than 6 is over here, and the bracket goes here, opening toward the shaded region. If I do write the interval notation, I'm going to write negative infinity to 6 with the bracket for the 6, because it's a less than or equal to, but with a parenthesis for the infinity because, well, for the negative infinity, because negative infinity always gets a parenthesis. It's not a real number. I'm not going to include it in the set, but it does mean all real numbers less than or equal to 6. So this is the interval notation, the graph, and the description of the interval. The second one was similar, but this time I have a compound inequality. So number 2 says negative 3 is less than or equal to x is less than negative 2. And I'm going to just graph that to start with. So the numbers are negative 3 and negative 2. On Hawk's number line, those numbers are actually very close together because they give you like from negative 10 to positive 10, and you just want this interval of size 1. But I think it's easier to draw and easier to look at the drawing if you give them a little bit of space. I want to shade between, because x is between those numbers, and I want a bracket for negative 3 and a parenthesis for negative 2. And like I said, you don't have to put the interval notation for this one. I'm not going to do it for this one, but I am going to identify this as, again, a half open interval. And it's like the bubble style where you choose half open or closed. And this is neither open nor closed. It doesn't include its endpoints. It also doesn't not include its endpoints. It has one and it doesn't have the other. So this is a half open interval. The next one was just to solve and put in interval notation, a little more straightforward or typical type of problem. This time with x minus 4 less than or equal to negative 6. And here's one that we actually have to solve first. One step, but we still have to solve it. I need to add 4 to both sides in order to isolate the x. X is less than or equal to negative 2. If I graph that, I need to find negative 2 on the number line. Less than or equal to means I have a bracket. And this set, it's the solution set of this inequality, it goes all the way down to negative infinity. So this is negative infinity to negative 2 bracket in interval notation. All right, the next problem is an application where we have to build our own inequality and solve it. So it's a little more complicated. Also, if you copy the whole problem down, there's a lot of writing. So I've abbreviated this a little bit. Here's the recipe. I need 2.5 times as many bottles of ginger ale as orange juice. And I'm going to start writing my equations and defining the variable, especially at this point. But the thing is, this problem is going to ask about number of bottles of orange juice. And what this is saying is that however many bottles of orange juice I get, I need 2.5 times as many bottles of ginger ale to make this punch, orange punch. Okay, so I have $20.60, and OJ is $2.90 per bottle. And ginger ale is 90 cents per bottle, $0.9. The question here is, what is the most bottles of OJ I can buy? And I think it's clear from the rest of this, I'm not just buying OJ. I'm not going to spend this much on each bottle for as much OJ as I can get. I want to make this punch, so I want to get whatever my number, let's call that number, let's call that number X for the number of bottles of OJ. And then I want to get 2.5 times that many bottles of ginger ale. Now, I can't really get a fractional bottle of ginger ale, but for instance, if I got 2 bottles of OJ, then 2.5 times that, 2.5 times 2 is 5. 2 bottles of OJ, 5 bottles of ginger ale. I think I can do better than that based on that I have $20.60, but I need to write an inequality, and I need an expression for how much money I'm going to spend. And it works like this. 290x. That's how much I spend on orange juice. X is the number of orange juice bottles, and 290 times that is the total amount on orange juice. Plus, let's see, how many bottles of ginger ale? Well, bottles of ginger ale are 90 cents each. And I need to get 2.5x of them. 2.5x because I need 2.5 times as many bottles of ginger ale as I get of OJ. And this has to be within my budget, so that has to be less than or equal to $20.60. And less than or equal to. It doesn't have to be less than. I can spend the whole amount of money. But I can't spend more than the amount of money that I have, so it has to be less than or equal to. And this is the inequality that I need to solve. I'm completely out of space, so. I'm going to do one step as I recopy this inequality up here, which is to write 290x plus, I can multiply the 0.9 and the 2.5. That is 2.25x less than or equal to 20.6. 20.60, we really don't need the extra zero here past the decimal point. It's money, so it helps to have it there sometimes. We don't need it for solving the equation, though. The next step is to combine these like terms. I got 515x is less than or equal to 20.6. When I combine these two x terms, you're adding 3-digit numbers, so calculator is a good idea there, so just to avoid mistakes. And then finally dividing by 515, definitely something to do with the calculator. To get x is less than or equal to 4. What is the most number of bottles of orange juice that I can buy? Along with sufficient ginger ale? That's the answer. So actually, the answer is not even x is less than or equal to 4. The answer is 4 bottles of OJ. The next problem I got is another inequality that has fraction expressions in it. And it's 2x plus 5 over 4 is less than x plus 4 over 3 minus 1. And there's more than one way to get this started. Now that I've done the problem and worked it out in a way that I thought was not too bad, I would do it differently. I would combine these two expressions. This one here, this is 3/3. 3 divided by 3 is 1. So I could do x plus 4 over 3 minus 3/3 and combine those into one fraction right away, and that's what I would do. I didn't do it in my work before, so I'm not going to do it now, because I think it is a straightforward thing, or a reasonable way to start by multiplying by the LCM. That's what I would do second anyway, but the LCM of the denominators, the least common multiple, work that over here, LCM, I need two factors of 2 and a factor of 3. In this case, these numbers are relatively prime. They have no common factors. So really the LCM is just their product. That's 12. And what I'm going to do with that is multiply on both sides by 12. You can write times 12 over here and times 12 over here, but I want to rewrite this to emphasize that we not only need to multiply both sides by 12, but on the right-hand side, we have to distribute that 12. 12 times this minus 12 times this. And I'm just going to write down that step and change that side. We'll do this in a moment. You could start distributing over here, canceling, but this is 12 times x plus 4 over 3 minus 12 times 1 is 12. And now you're going to see the reason that we multiplied by the LCM. It makes the fractions go away, which is easier to deal with. The 12 and the 4 cancel, leaving a 3. Right? 12 divided by 4 is 3. So I'm going to have 3 times 2x plus 5 is less than, here, the 12 and the 3 cancel, leaving a factor of 4. But that's 4 times x plus 4 minus 12. Next, I need to distribute on both sides. 3 times 2 is 6x plus 15 is less than 4x plus 16 minus 12. And I can combine like terms on that right-hand side. 6x plus 15 is less than 4x plus 4. 16 minus 12 is 4. So that's where we've gotten to. I'm going to recopy that to do things to it. So 6x plus 15 is less than 4x plus 4. I want to get the variable isolated from the number. I'm going to do that with terms first. Let's subtract the 4x from both sides to get rid of the x's over here. And 2x plus 15 is less than 4 is the result of that. You could do this next step at the same time as that, but don't feel like you have to. One step at a time is a very good way to do it. Because each step has more than one sub-step. So it can get really complicated if you try to do more than one. But this is -11. Yeah. This next will be the last step in the solution here. So subtracting 15 from both sides, I get 2x is less than -11. Finally, divide by 2. X is less than -11 over 2. And that's the solution. That's the algebraic notation for the solution. I'm going to draw the number line. The only number that matters here is -11. -11 over 2. That's the only number in my expression. Less than means to the left of. And it's strictly less than, so I need a parenthesis there. If you're typing this into Hawks for the graph, you need the 2 parenthesis symbol, not brackets, not a bracket and a parenthesis, but both parentheses. And that's also what you would use for the interval notation. So if Hawks asks for this, both parentheses, negative infinity is where this interval starts on the left. It doesn't really, it's not a place, it's all the way down the number line. But the right endpoint is 11/2, but we're not including it. This is an open interval. The next one, 6, illustrates a property of inequalities that I don't remember seeing yet this semester. We may have done this once or twice, but this is a one-step inequality, only one step to solve it. Completely simplify it. I needed to divide both sides by -4. So over here, the -4's cancel and I get my x by itself. 28 divided by -4 is -7. And this becomes less than. Because I divided by a negative number, the direction of the inequality flipped. It's easiest if you just remember that. When you multiply or divide by a negative, you reverse the direction of the inequality. That's just how the number line works. If you multiply by a negative, you're basically flipping across zero. And if both of them are flipping across zero, they exchange positions relative to each other, left to right. But that's it. That's the simplified inequality. So if I graph that with the number -7, less than 7 gets a parenthesis, and the interval notation -infinity to -7. The next one is an algebraic inequality, and it's a single inequality, not a sandwich, but the algebraic expression is a little bit complicated. So we've got some simplifying, and it'll take several steps to simplify this. First, I'm going to distribute -6z minus 8 is greater than or equal to -2z minus 16. Let's add the 2z to get -4z minus 8 is greater than or equal to -16, and then add the 8 to get -4z is greater than or equal to -8. And finally, divide by -4. Actually, exactly the same number we did in the last problem. But the important part is not that it is the same number, it's negative. We're dividing by a negative. We're going to have to flip that. So the -4's cancel, that was the point. Less than or equal to -8 divided by -4 is 2. But the important part here is that I changed this from a greater than or equal to a less than or equal to. My number line graph would be I'll label 2 and then less than 2 and a bracket as the punctuation on there to show that it's a less than or equal to. The interval notation would be -infinity to 2 with a bracket on the 2, but of course a parenthesis on the -infinity, because always like that. All right, the next one is another application problem or a word problem. And this one is about a delivery driver. A driver makes $45 each day. And $7 in tips for each delivery. I think the actual problem said it was an average of $7, but we're just going to call it $7 in tips. If he wants at least $206 in one day, at least how many deliveries does he need? And this at least should it should get you thinking about the phrase less than or equal to. So at least, I just said that wrong, sorry. At least is greater than or equal to. If I have at least $5, that means I have $5 or more. So the amount, if it's at least a certain amount, we want to make it as a greater than or equal to. We'll look at that with this inequality too, but let's first think about with x equal to the number of deliveries. And that's what we're asked about here. How many deliveries? We're going to make an inequality that expresses, well, we want at least this much money. The total amount of money we get is 45 plus 7x. So $45 the salary that he makes each day. And then 7 times the number of deliveries, because $7 for each delivery. This has to be at least 206. At least. Means it has to be greater than or equal to. We want to make at least this much money, so our earnings, based on the number of deliveries, has to be greater than or equal to that number 206. And this is just an inequality that we can solve in a couple steps. 161. Yeah. And then finally, to solve this, I just divide by 7. That gives me x is greater than or equal to 161 divided by 7 is 23. And that's actually the number we're looking for. He's got to make at least 23 deliveries to get at least $206. If he makes more deliveries, that's fine, but fewer deliveries will mean less than this amount. So we need to have at least 23 deliveries. Finally, for number 9, negative 3z minus 6 is less than negative z plus 5. I'm going to do the steps one at a time. I'm going to get the variables over here by adding z to both sides. That gives me negative 2z minus 6 is less than 5. And then get the numbers over here, plus 6 plus 6. That gives me negative 2z is less than 11. And then if I divide by negative 2, over here I just get z. And over here I get negative 11 over 2. The negative, if you have to type this in Hawks, the negative should go upstairs or in front of the whole fraction. A negative in the denominator is considered unsimplified. So we have to simplify. But the main thing going on here is I divided by a negative number, so I need to flip my inequality. Hawks might call that changing the sense of the inequality. I like to call it the direction. This inequality is actually pointing to the left. It's not an arrow. It's the alligator that eats the larger number.